Okay, we're going to go on to Chapter 7, Section 6, and remember, the notes, even though they say honors, it's the same notes we use in honors and regular. So congruent are figures that have the same size and shape, and the similar for congruent is an equal sign with a wavy line over it. Similar are figures that have the same shape but not necessarily the same size. So they're going to be in proportion to each other, kind of like the, 1/2 equals 3/6. They aren't the same. The second one is 3 times bigger than the first, but they're still, the side lengths are in proportion to each other. And scale factor is the ratio used to enlarge or reduce similar figures. Okay, so for polygons to be similar, a couple things need to happen. The corresponding angles must be congruent. So the angles that are corresponding, like let's do this. Now, I know I'm not a good artist. Pretend these are similar. The corresponding angles, like this angle and this angle, would need to be congruent, exactly the same. And the corresponding side lengths are proportional, just like this angle and this angle and this angle and this angle would need to be the same. And then the corresponding sides, let's go into a different color. This side and this side would have to be proportional to each other. This side and this side would have to be proportional to each other, and this side would have to be proportional to each other. And actually, I just put equal, so that was bad. I'm going to erase that. That was bad writing because they're not equal. That symbol that I just gave you was for equal. So let's go back here. These would be the same. These would be the same. These would be the same. And then the side lengths would be proportional, the ones in the same spot. So this and this one and this one. Okay? So let's get into this here. So a painting of is 40 inches tall and 56 inches wide. So we're going to have tall over wide, because remember I always like to write the words out. Okay, so that's 40 over 56, and since they're both in inches, it's okay that we don't write down the units. Okay, so then it says, is to be scaled to 10 inches tall, so for inches, for tall, I'm going to put 10. How wide should the painting be? So we don't know the width, so that's why we're going to put a variable x, or any variable you'd like. It says, how wide would the painting be on the poster for the two pictures to be similar? And then find the scale factor. Okay, so first of all, let's go back to the scale factor, and we have the inches tall and the inches tall. So we have 40 inches tall on the original and 10 inches tall on the other one. So since they're both in the height, that's going to give us our scale factor. So 10 divided by 40 gives us 1/4, and 1/4 would be 0.25. So your scale factor is 1/4 or 0.25. Okay, so now we're going to use our ratio, or excuse me, our proportion here that we came up with, our two ratios, and we're going to cross multiply and divide, or you can do the other method. Let me get a different color here. Let's do purple. 40 divided by 4 is 10. So 56 divided by 4 is 14. Okay, so you could do it that way. Or you can cross multiply and divide. If you cross multiply and divide, 40 times x is 40x. 56 times 10 is 560. Undo multiplication with division, and you're still going to get x equals 14 inches. So it doesn't matter. Whichever way you choose is fine with me. Okay? So a t-shirt design includes an isosceles triangle. Okay, so I'm going to draw an isosceles triangle. So I need to remember that isosceles means at least two sides are the same. Okay, so these two sides would be equal. And it tells us that the lengths are 9 inches, 9 inches, and 12 inches. An advertisement shows an enlarged version. Okay, so we're going to make another isosceles triangle. And the side lengths are 3 feet. And 3 feet, okay, and then this is x. What is the length of the third side? Find the scale factor. Okay, now the problem here is we don't have our units in the same dimensions, so we need to turn our 3 feet into inches. Just makes it a little bit easier. So 3 feet is equal to, remember, horse to fly, multiply feet to inches, 3 times 12. This is going to be 36 inches and 36 inches. Okay, so now we take a pair of sides that are the same location, the same similar sides. So we have 9 inches over 36 inches. So if we divide those each by 9, we're going to get 9 divided by 9 is 1, 36 divided by 9 is 4. So 1/4 is our scale factor because it asked us to find the scale factor as well as the side length. Okay, so now for the side length, we take two sides that we know and set up a proportion. So we can use the 9 over 39 over. Now, you can do one of two things here. You can have a rate where you have inches over feet for this point, okay? So 9 inches over 3 feet equals, now go to the other sides that you don't know. So we have 9 inches over 3 feet equals 12 inches over x feet. So you can have a rate, not the same units, when you're doing the proportion, just not for the scale factor. So 9 doesn't go evenly into 12, so on this one we are going to have to cross multiply. So 3 times 12 is 36, so 36 equals 9x. Undo multiplication with division. Sorry, I'm running out of room here. And 36 divided by 9 is 4, so x equals 4 feet. So that means this side right down here that's missing would be 4 feet, or it could also be 48 inches. Okay? Okay, so I'm missing part of this figure, so I'm going to draw it in real quick. Let's see. It says, on the other page and on your page, it says which rectangles are similar, and it says, if any, find the scale factor. So we need to add if any, meaning if any are similar, find the scale factor. Okay, so first we need to see if they are similar. So let's see. We're going to do triangle J and K. So we need to take the sides that are similar to each other. So 10 over 5 equals 4 over 2, because then 4 and 2. Okay, so we cross multiply here, and we get 20 and 20. So yes, J is similar to K. Okay, then we're going to do J and L. So this is J, and this is K. Then let's do J and L. So that's 10 over 12 equals 4 over 5, because this is 10 and 12, 4 and 5. So we cross multiply here. And we're going to get 50 and 48. So J is not similar to L. And then we have, what did I miss? K and L. So K and L. Okay, so K is 5, L is 12. So we have 5 over 12 equals 2 over 5. Okay, so we're going to cross multiply here. And we're going to get 25 and 24. So K is not similar to L. Okay, so now that we've done that, we need to go back to the one that is, sorry about that, which is J and K, and we need to figure out the scale factor. Okay, so to figure out the scale factor, we go back to the original figures, and we pick a similar side on both. So I'm going to scroll down here, and so we have 5 centimeters on K and 10 centimeters on J. So since K is the smaller, we're going to have K over J. So the side length we just said is 5 over 10, and they're both in the same units, which reduces to 1/2. So the scale factor is 1/2. Okay? Now, if you pick the other side lengths, if I go back here, we have 2 and 4. We should get the exact same scale factor. So 2 divided by 4 is also 1/2. So that shows us that that scale factor is the same for the entire figure, which it needs to be. Okay? So last one with our fabulous tree here. All right, so let me scroll up so I have a little more room. A tree casts a shadow that is 40 foot long. Okay, so I'm going to draw a tree. And we're going to draw a shadow. The shadow is 40 feet long. At the same time of day, Fred casts a shadow, so Fred's not as tall as the tree. So Fred has a shadow that is 15 feet. Okay? And Fred is 6 foot tall, so I'm going to make this in red, 6 feet. That's Fred's height. Write a proportion to find the height of the tree. So that's what we're missing right there, which is the height of the tree. Okay, so we need to set up a proportion. Okay, so take everything you know about. So we're going to have height over the shadow. Okay, height of the person or the tree over the height of the shadow. So the height of the tree is x, and the shadow is 40 feet. And then the height of Fred is 6, and the shadow is 15. Okay, so that is your proportion. Okay? So now we are going to cross multiply. So 40 times 6 is 240. Okay, so like I said, 240 equals 15 times x is 15x. Divide by 15, and you get x equals 11 feet. So that means the tree is 11 feet tall. Now, you could have set your proportion up differently. You could have done everything for the tree over Fred. So for the tree, we have x, and then for Fred, okay, we're going to cross this out. Excuse me. We could have done x over 6 equals 40 over 15. So what you did here is x and 40. So everything for the tree is in your numerator, and everything for Fred is in your denominator, which is what I was just saying. So x is the height of the tree, 6 is the height of Fred, x is the shadow of the tree, 15 is the shadow of Fred. Okay, so again, you cross multiply. And you get 240 equals 15x, same deal, and you get x equals 11 feet. Okay, so have a good night, and we will see you in class tomorrow.